Thanks for joining us today. Our topic is decision modeling in Python, going from Notebook to Nextmv. I'm Renuka Goff. I'm on the product marketing team here at Nextmv, and our host for today is Nicole Missick, our VP of Decision Engineering. Our agenda for today is to briefly cover the Nextmv platform and decision ops. We'll cover our Python SDK and how it accelerates your workflows. And then our heart of the presentation will be the demo, where Nicole will walk through how to deploy and test a Gurobi model from a Jupyter notebook. And we'll, of course, save time at the end for Q&A. So throughout the session, feel free to use the chat or the Q&A feature. We will have some folks from Nextmv on the call as well. So feel free to ask your questions throughout the presentation. And just make sure to toggle between hosts and panelists and everyone, depending on who you'd like to see your question. So feel free to jump in and say hello as we get started. So if you're new to Nextmv, Nextmv is a decision science platform, and our platform accelerates decision and data science teams with these core offerings. So we provide decision ops tooling, which includes simple deployment, like you'll see today, production infrastructure, a testing framework, collaboration features so you can work together with your team, and a system of record for your model so you can see when the last model was pushed up, and versioning as well. We have optimization integrations with popular modeling tools and solvers that you likely already use and love, like Gurobi, OR tools, Ample, Highs, Hexely, others that you're likely familiar with. And we also offer Decision App Quick Start. So like the name implies, those help you get started really easily with pre-built models for common use cases like routing and scheduling. And of course, those are all available to be customized as well. So I'll show this slide just briefly to highlight the decision ops core themes that I mentioned just in the earlier slide. These themes are fairly common across other disciplines like DevOps and MLOps. So here at Nextmv, we're bringing that same standardization and transparency to decision science. So what does this mean for your team? If you're an ops researcher, a decision scientist, or data scientist, this means you can focus on modeling rather than building and maintaining decision ops tooling. And for software and engineering teams, using Nextmv means being able to integrate decision models as decision services into your workflows, and then monitoring them like any other service. And if you're a business stakeholder, Nextmv allows you to see exactly how the models are driving values with specific KPIs. And this is done through interactive dashboards and shareable reports. So why are we talking about notebooks for this presentation? Notebooks, as I'm sure most of you on the call know, are very common starting places for prototyping models. And that's for a number of very good reasons. Notebooks are familiar to many decision and data scientists. They're a nice, easy way to tell a story and conduct simple tests within the notebook. And of course, there are a bunch of really great examples that start in notebooks from tech like Gurobi and Ample, and one of which we will get to in just a moment. But what happens next when you're ready to go from the notebook to the next step, when you want to see how it performs under different conditions or share experiment results with your team, or maybe start comparing it to other models? So let's talk about how the Nextmv Python SDK can help make your life a little bit easier. So the Nextmv Python SDK lets you bring your model to the Nextmv platform in a few minutes. So you can develop, deploy, test, and manage your own Python model on the Nextmv platform. So what we'll see today is how easy it is to deploy your model from any Python environment like a notebook. So the SDK really allows you to prototype faster, get to production safely, and manage and scale efficiently. For today's demo, we're going to look at an example that's probably familiar to many of you. This is the Gurobi avocado price optimization model. And the goal for today is to find an optimal avocado price, and that will be done using a blend of descriptive, predictive, and prescriptive analytics, which Nicole will walk us through. So today, Nicole will walk through, like I said, going from a Gurobi model that's in a notebook on the left-hand side here into the Nextmv platform. And the benefits to doing so is that you can really turn your local model into something that now your whole team can work on and interact with. They can run tests on it, they can share test results, see metadata from runs, and really help you prototype faster. So with that, I'm going to hand it over to Nicole to jump into our demo.
Thanks, Renu. So as Renu mentioned, I'll be talking through the Gurobi avocado price optimization notebook and how easy it is to extend what Gurobi has done here to deploy to Nextmv. So at a high level, this notebook is composed of 3 different pieces. First, the Gurobi team has done some exploratory data analysis to better understand the relationships between sales and price, along with other variables. Second, they've leveraged those learnings to build a prediction model to predict demand for avocados as a function of price and those other factors. And then lastly, what they've done is walked us through how they create an optimization model, which sets the optimal price of avocados and supplied quantities in order to maximize net revenue. So what we've done is we've downloaded Gurobi's existing avocado price optimization notebook, and we've made very minor modifications to it. So I do want to say we can't claim any credit for the model logic itself. All credit here goes to Gurobi. And so given that, we're not going to go through the model logic in a ton of detail, but I will focus on the minor extensions we've made to it. All right, so jumping in here, they start with pip installing some necessary packages for the exploratory data analysis. Then they do their imports. Here we're reading in the avocado data, which is a CSV file that they have hosted in GitHub. Now we're preparing that data. All right, so now we get to the first piece, which is that EDA, observing the trends in the data. So here they're looking at sales over the years. Then looking into seasonality, looking at the relationship between sales and month. And then they produce this nice correlation plot to see that what factors are most correlated with sales. And we can see here that sales is negatively correlated with price, as one would expect. They look into regions. They see that West Coasters love their avocados. All right, so now we've done kind of a really quick drive-by of the EDA portion of the notebook. So then they go into predicting predicting demand from sales. And so what they've done is they've taken those learnings from earlier on in the notebook and built this regression model to predict demand as a function of price and other factors. And they're using the stats models package to split the data into a training and test set. And observing that the R squared is 0.89, which is pretty good. So then they fit the model to the larger training set. We see that R squared is 0.90. All right, so now we're ready to go into the optimization piece. And so this section really nicely breaks down kind of how to build up that optimization model and incorporate that predictive model into it. So what they start with is instantiating the Gurobi model and the parameters that it needs. So you can see here that they've really defined all of those parameters in line in the code. We're going to come back to this later and talk about how this can be split out. So then they define the decision variables. And here we create the expression to capture the relationship between demand and sales. And here, setting the objective to maximize net revenue. Adding some constraints. This is a supply constraint. Here is a sales quantity constraint, wastage constraints. All right, and now ready to optimize. And so we can see that we found a solution. The optimal solution has a net revenue of 42 million, and we found that solution in under a second. So once we have that solution, we want to obviously visualize it. And so what they've done is they've started with this pandas data frame where they show by region the price, the optimized price, optimized allocation amounts per region, along with sales, wastage, and predicted demand. And so lastly, just visualizing that solution and showing the sales versus price by region. All right, so now we're ready to talk about the minor extensions that we've made to this notebook to deploy to Nextmv. So starting out, we pip install the Nextmv Python SDK along with all of its optional dependencies. We import the packages that we require for this model. And so now comes kind of the core changes that we need to make, which again, it's just a few lines of code. So you can see that we label anything that's sort of Nextmvified within these little comment blocks. And so what we need to do to take this from local to pushed up to Nextmv is create a decision model class or Nextmv model class using the Python SDK. And so we've created that class and called it avocado price decision model. And we've defined a function on that class called solve. And so the expected signature of this solve function is that it takes in a Nextmv input and it returns a Nextmv output. So that's what we've done here, is we've defined that function. We've also just added this line of code to redirect any of the Gurobi solver chatter to standard error from standard out, so we can preserve any standard out printing for the output itself. And so then what we've done is really just copy pasted everything that we just went through above into the solve function. So this is all just existing code. And then the only other changes we make are at the very bottom of the solve function. We've created the statistics block, and the Nextmv statistics is a class in the Nextmv Python SDK that helps you to conform to our statistics convention so that we can do some nice things with it, like automatically pick it up and surface it for your run history and use them to compare in experiments. And so what I've done here is I've just passed in that optimized revenue as the objective value for the statistics. And then I've added some custom statistics for number of variables in the model, number of constraints, and the total wastage. And then lastly, since this solve function needs to return a Nextmv output, we do just that. And that Nextmv output is composed of options, which in this case, there are none. The solution, which is that pandas data frame that we had created up here, and the statistics block that we just created. So that's really it. It's just a matter of creating that class, defining the solve function, doing some copy paste of the model logic in there, and adding the kind of the wrappers around it to take in input and return output. So I will go ahead and run that.
While you're running that, Nicole, I just wanted to call out how you did walk through kind of what each of those pieces mean, but really it's just a few lines that you've added there. And I know we've started to get some questions in the chat around this notebook being available. So it's really cool is that Nicole's taken the Gurobi notebook example and just added little pieces of code from Nextmv. So we'll make sure that those pieces of code are available. But yeah, very cool to see how you're actually using the Gurobi example itself.
Yes, thank you. Cool. All right, so before we go ahead and deploy to Nextmv, it's best practice to run this locally and make sure that it runs. And so what we've done here is we've instantiated the model with that class that we created. we've created an input, which is, again, that Nextmv input. In this case, if you recall, we define all of our data really in the code itself. So there's no data that's being passed in externally. And so for this portion of the demo, we're just going to pass in basically nothing for the data. That's not something we would recommend when you're running in production. But what I wanted to start with is really just the bare minimum of what you would need to do to push an existing model up to Nextmv. And then we'll talk about the likely ways that you would extend this. So in this particular execution, we don't have any data and we don't have any options. We can just pass in the empty set of options here. And then we're really just running that solve function, passing in the input, and we get a Nextmv output. We can see that we got that same solution of 42 million in net revenue. So we can see that we preserved the model result, and we haven't made any changes to the logic, obviously, when we added those wrappers. All right, so all went well locally. So now it's time to push the model up to the Nextmv cloud. And so to do that, what we start with is creating a client with Nextmv. And we configure that using the Nextmv API key from your account. I have this set as an environment variable, so that's what I'm using here. And then we define the application that we're pushing our local code up to. So in this case, I have an application called Avocado Price Optimizer on Nextmv, and I just want to take my local code, push it up there. We also define some model configuration, like the name of the app and any Python requirements that we need to bundle up with that executable when we push it up to Nextmv. And in this case, we don't have any options, so we're leaving that as empty. And then we create an app manifest using the Nextmv Python SDK, just passing it that model configuration that we just talked about. And then lastly, we deploy those local changes or the local code up to the application by passing it an app manifest so it knows how to run it and what it needs. The decision model object itself, the model configuration, and then we just log all the steps along the way. So this takes a couple minutes to run, so I'm not going to run through it now, but I have left the output here for you to see what that looks like. And you can see that we did successfully deploy this, and we have our own custom endpoint now that we can make runs against. So now it's time to try running it remotely on the Nextmv cloud. And we can do that in a couple of ways. So one is we can use the Python SDK to do that using the application.new run with result function. But what I would like to demo is doing this on the platform. All right, so now I'm in the Nextmv console. And what I will do is go ahead and click into a past run here. And actually, before I do that, let me give you a lay of the land here. So you can see that I last pushed up an executable February 11th at 3:12 p.m. And so when you push up something using that application.push function from Python, you will then see that this executable changes to whatever version you've just pushed up. And I'm going to run through a few of these other pieces in a moment, but I will just kind of quickly jump into my run history. I'm going to go to a past run that I made, and I'm going to go ahead and clone this just so you can see how I ran with it. So let's take a look at the input. This text editor is where you can paste your input. In this case, if you recall, I don't have any input because it's all defined within the model itself, which is not something you would typically do. So I'm passing in null here. And so I'm going to go ahead and hit run. And so what we see is that the details page shows kind of the metadata about the run, shows the status of running. And you can cancel it if you need to. And once this completes, we'll see our output and our statistics. Just giving it a refresh. There we go. Okay. And so now you can see those statistics that we exposed with the Python SDK are here. Our net revenue is the same, total waste, and so on. Again, we see our input was null, and our result here is a JSON file, which has the regions, the recommended price, and allocation amounts per region, and so on. All right, so let me switch back. Okay, so now let's talk about some logical extensions that you would likely make here when you're doing your model development. So typically what we see is that the data itself is split out from the model and it's not kind of embedded in the model code. So what I've done here is I've created a Python dict, which basically just has all of that data in it. And then I'm going to show you the kind of the changes that we would make to the class, the avocado price decision model class, in order to read from that data object. So everything here is exactly the same as what we just went through, with the exception of here, we're adding a line for just basically receiving that data from the input. And then down below, now instead of defining all of those parameters within the code itself, we're just reading from the data. Now, I didn't put this in a Nextmovifying block because this is really kind of just separate from Nextmove, but it allows you to kind of have a better experience on the platform if your code is disconnected from your input. So again, everything else is the same. So we'll just go ahead and run that. And now, again, best practice to just run it locally and make sure everything works, which it does. And we got that 42 million number again. In this case, we are now passing in data and options to the model itself. And one thing, actually, let me go back and I forgot to talk about is we are receiving all of these parameters from the data with the exception of one parameter, which I wired up as an option. And so what this allows you to do is actually run experiments and vary this parameter from the console itself, which is really helpful. And I'll demo that in a moment. So now we have options for the supply quantity. And so what we're doing here is we're defining those options, saying supply has a default value of 30. This is the total amount of avocado supply in millions of avocados that we're basically trying to distribute and price. Okay, so that ran locally. So now we're ready to push it up to the Nextmove cloud. And so again, the same process applies here. We're creating that client, creating the manifest from the configuration, and then pushing it up to the application. All right, so before I switch over again to console, I did want to mention briefly the experimentation piece of this notebook. So I left what Gurobi did in here in an appendix because I just wanted to highlight that they kind of went through some of these steps here in order to expose the ability to vary supply configuration and run an experiment on that. And so this was a really cool experiment that I wanted to show you how you can replicate in the Nextmove console. And it's really nice because if you do it in the console, then you can kind of expose that ability to experiment with these configurations without having someone working out of a notebook, and they could have kind of a UI around it. So I will switch back over. All right. So versions are essentially a version of that executable that I pushed up. So if I click in here, what I've done is I've pushed up a version of that model that splits the input from the config. And best practice here is to name this with like a commit SHA from your GitHub model. And so this is really nice because you always know what version of the code is running behind the executable. So that's a version, and I previously had cut a version for this on February 11th. And then instances are really the endpoint that you're making a run against. In this case, I created an endpoint called staging. And the instance itself is a version of the executable plus any default configuration that you want to apply to it. In this case, I don't really have any default configuration, so I just have this, this version that it is tied to. So let's make a quick run here. I'm going to illustrate on a past run again, and I will clone this just so you can see what I'm doing. Okay, so now instead of having null here, we have actual data on the regions, the total amount of supply, the transport costs, and so on. We're running on our staging instance, which is that version of the code that had the input split from config. And now we're passing in, because we expose supply as an option, as I did in the code, now you can actually just enter that configuration directly in the console here. We can hit run, and you can see also we pick up the configuration that you ran and we surface that in your run details. So, often we'll see a big tabular list of configurations here versus just the one. Okay, so that succeeded. And so now we can always get our input and the result based on that input. And again, we have the same result that we were seeing before, but now that input is split out from the configuration. And one thing I didn't mention before is you can always go into logs and see anything that you're printing to standard error. So in this case, all of that solver chatter from Gurobi is being printed here because we used that Nextmv redirect command in the code. All right, so now very quickly, I want to show you a scenario test. I'm going to continue using the clone feature to show you how to construct a scenario test or a scenario plan. So what I want to do here is a similar experiment to what Gurobi did in the notebook. I want to compare if we have different starting supply amounts, how does that change the solution? And so what you can do here is you can upload files directly that you want to run with, or if you created an input set in the platform, you can use that, which I will do here. I'm running against my staging instance. And now instead of passing in supply of 30, I'm going to pass in a supply of 20, 30, 40, 50 million. And I want to know what the impact is on my statistics for each of these values. So I can go ahead and hit run. Move everyone's faces. Okay. All right. So now that's running, and you can see all of the child runs. And I know we're running up against time. I promise I'm just about done. So you can see all these child runs running here. You can see that you can click into them if you choose and see kind of that run level data that we just went through. And these should finish momentarily, and then we will see a nice pivot table, interactive pivot table that you can work with. All right, so now that that test completed, we can see we're visualizing the objective value, which is net revenue. We can see at 20 million avocados supply, we have 35 million in revenue. Then when we bump that up to 30, we have a larger net revenue. And then when we bump it up to 40, we go back down to a lower net revenue, and so on. So it's not kind of that linear trend. And Gurobi did highlight this in their notebook, that the reason for this is because when you're oversupplying the avocados at the beginning, then now you have to account for the wastage of those avocados that don't get sold. And so that's why we're kind of seeing this nonlinear trend. And so what we can do is actually just confirm that, and we can click into total waste. And we see here that, yes, that is what's happening. As we increase the supply, we see that the total waste also increases. All right. So that is all I have for the demo portion. I think we just have a quick summary now.
Yeah, thank you so much for that demo, Nicole.
Yeah, so what just happened? I ran the Gurobi avocado price optimization notebook. I added a tiny bit of code to Nextmovify it, deployed it to Nextmv from the notebook, and then I ran the model remotely using the Nextmv UI. Then we went back to the notebook and we split out the input and configuration from the model, redeployed that up to Nextmv, and then we did a scenario test where we varied supply and looked at the relationship in the statistics. So what happens next now? So if I were to continue with this project, what would I do? I'd probably run some more experiments to get a solid prototype to work with. Then I would consider at that point probably moving out of a notebook and into kind of more conventional Python scripts and using a repo. And then that way I can use kind of Git and incorporate CI/CD into the workflow to auto push versions up. And then I can compare different models using the Nextmv experimentation tooling. I can share results or links with stakeholders to get their buy-in. And when I'm ready, I can promote a new model to production and just manage that whole experience with Nextmv.
Wonderful. Thank you so much, Nicole. It was a packed presentation with a lot of great stuff in there. We are a little bit over time, but I am going to sneak in a question for anyone who's still able to hang out with us for another minute. Okay, we have one that came directly to us. Why does it matter to split out IO and config?
Yeah, so that is a really good question. And basically, what we recommend here is that you kind of disconnect your input from your model so that you can preserve the like the model itself and make changes to that separate from the input. And that's really what you would do in a production environment anyway. You would not want to redeploy your model every time you change your input, right? You would want to redeploy your model when you're making changes to the logic, and you would want that to be able to receive from the outside different inputs when you're running in production. So that's definitely more typical, but sometimes in a notebook experience, it's just easier to kind of write things in line when you're experimenting.
Got it. Makes sense. Okay, well, I think we'll wrap up since we are a little bit over. I just wanted to say thank you to everybody for joining and Nicole for the wonderful demo today. We are over time, so if there were any questions that you didn't get to ask, we will make sure to answer them via email. Please reach out to us. We'd love your feedback and questions. This is what we really enjoy doing, is starting these conversations. So please reach out to us. To try what Nicole did today, you can get started at nextmv.io. And we have another tech talk coming up in a couple weeks about improving how business users interact with optimization and decision models. So stay tuned for that invitation, and we hope to see you there. Thank you again.